In this video, we're going to be talking about compound inequalities. This is section 1.6, and this will be the final lesson, or the final section, I should say, of the chapter. And so I've decided in an effort to try to get you to understand some of the nuance between compound inequalities, just to try out this example using a deck of cards. So I am assuming there's some familiarity with the deck of cards, which I think is accurate for most students. There are 52 cards in a deck, broken up into 4 different categories: uh, clubs, spades, diamonds, and hearts, 2 of which are red suits, and 2 of them are black suits. And then there's ace through king, which is 13 cards in each suit, starting with ace and then counting up 2, 3, 4, all the way to 10. And then we have 3 what we call face cards: the jack, the queen, and the king. All right, so let's assume we're playing some sort of contest. And in this contest, you're going to draw a single card. So on part A, you draw a card, and you're going to win if the card that you drew is red and a face card. And so the question I have is, what are some of the winning cards there? And then, if you can determine it, how many cards would be a winner? So consider these scenarios, A, B, C, and then obviously my numbering got off, D, E, F on the other side. And then check back in and see if you're coming to the same conclusions that I do. All right, so if you draw a red and a face card, so only a red face cards would work. So that would mean things like the jack, the queen, and the king, but only those that are hearts, and those, the jack, queen, king of diamonds, right? So those would be the only cards that would be red and also face cards at the same time. So it looks like there's 6 out of the 52 that would be winners. All right, part B. You win if the card that you drew is red and even. And so now the only cards that would win this time are the red ones, again, the hearts and the diamonds, but all even cards. So that would be like the 2 of hearts, 4, the 6, the 8, the 10. I guess we could make an argument, since the queen represents 12, like we could include queen in that or not, depending on your own personal, how you thought about it. And that would be, again, all of those for hearts and all of those for diamonds. And so we'd have what? Depending on, again, the queen, 1, 2, 3, 4, 5, 6, you'd have about 12 cards that would win in this case. And then this last one on this side, you win if the card, and this is kind of a silly question, I was trying to make a point, if the card that you drew is a 3 and a king at the same time. Well, obviously there are no cards that have a 3 on it and a king on it. So there are 3s and there are kings, but there are no 3 kings, right? So there are no cards that match this criteria. All right. And the key here is on all of these, there is this word and. And when you're talking about and, that means in order for it to match the criteria, it has to actually match both of the criteria, right? Just being a red card alone didn't get the job done. It had to be a face card also. So red and face card, red and even, a 3 and a king at the same time, and there are none. All right, the other 3 are similar. You're going to win this contest if you draw a red or a face card. So now we're dealing with this word or, and it is significant, especially mathematically, the difference between those 2 words. So this time, if you draw a red card, you're a winner, or a face card, you're a winner. So now there's a lot more possible ways to win, because there are 26 total red cards. Some are face, some are not face, but again, this just says you're going to win if it's red, or you're going to win if it's a face card. And so then there's a bunch of black face cards. So there's 6 more black face cards. I know there's more face cards, but we already counted the red ones in the red category. So 6 black face cards. So lots of winners now. Now 3 of diamonds wins, 10 of hearts wins, Jack of clubs wins. So there's a lot more possibilities. The next one, you're going to win if the card you draw is black or even. So now we've got all the 26 black cards are all winners. But also then all the even reds are going to be winners. And so we already did the even reds over here, right? That's 12 more cards. So 26 and 12. Lots of winners. And then this last one, you're going to win if the card you draw is a 3 or a king. Well, this time there are 4 threes and then there are 4 kings. So there's 8 possibilities here. We don't have to meet both the possibilities. We just have to satisfy one of the conditions. All right, so that's and or. Now, I think I may skip over this portion, but I had you in class kind of come up with kind of your own scenarios. So maybe we'll do like a handful of these. Come up with conditions where only 4 cards in the deck will win. And honestly, like I kind of was not in a very creative mindset, and I was having a hard time coming up with one of these in one of the classes. And then we came up with maybe something like this. If the cards are black, so that's a lot of cards, and at the same time, less than, let's see, less than 3. So then the cards less than 3, if you count the ace as a 1, that would be an ace and a 2. So only 2 cards per suit. And we've got black, so that would be the ace and 2 of clubs and spades. So that would be 4 cards, just as an example. Come up with conditions where half of the cards will win. We could maybe do an or on this one. We could do an and, I guess. Any scenario that when we count them up, you get half of the cards. So that could be as simple as kind of like we did a second ago, is we could say, we could maybe do conditions with or. We could say all cards less than, I'd have to do the math to figure out how many we would need, but like less than 5, we'll say. So then that's 1, 2, 3, 4 of all cards. So there's 20 cards right there. Actually, if I say less than 4, that'd only be 16 cards. Or less than 5. 1, 2, 3, 4. That's only 16. And then I need maybe, and then all cards greater than some number, and I'd have to do the math to figure out how many more cards we need, et cetera, et cetera. But again, the idea is limiting the conditions to make that work. So let's kind of jump down. Part G, we've already kind of done that one. Come up with conditions using and where no card will win. A really easy one on that would be that you have to draw, the card that you draw has to be red and black. And there are no cards that are red and black, right? So no conditions overlap. Plenty of red cards, plenty of black cards, but none that are together. All right, I'm going to go ahead and skip ahead because I think we get the idea. And now let's just transition this concept into numbers. So here's this and we've been discussing. So and means that numbers, so I'm going to switch over to numbers now, must satisfy both conditions to be solutions. So here's an example. Remember, we have 2 different ways of writing our sets of numbers. So one is the set builder notation. So condition 1, x has to be less than or equal to 4. And so when we look at all the numbers less than or equal to 4, and there are an infinite number of them, we would have all the numbers that go forever this way. So every number over there matches that condition. That's sort of like having a red card, right? And then we also have the condition that all those numbers we're talking about, they also have to be greater than 0. So that would be all the numbers this way. And so what are the numbers that we're talking about? That would be the numbers that satisfy both. And that's what's been highlighted on the number line. All numbers greater than 0, but also at the same time have to be less than 4. 0 is not included because while 0 is part of this set, it is less than 4. It is not part of this set, which is greater than 0. So we had to leave it out. 4 is a solution to both. 4 is less than or equal to 4. 4 is greater than 0. So 4 is good. Oh, we leave 0 out. All graphing goes on the number line, remember? So I would consider these little lines I drew sort of like my scratch work, right? But the actual answer needs to be then indicated on the number line. All right, so some possible solutions, numbers like 0.1, that would be in here someplace. There's like 0.1, 0.7's in there, 1.3, 2.4, 4 is a solution, 0 not a solution, right? So things that aren't solutions would be anything that doesn't meet both criteria. So that would be anything out here and anything out here. All right, I think you get it. Let's move on. So what does OR mean? Or for the number to be a solution, it has to satisfy only one of the conditions. So in this case, we've got x is less than -3, not including -3. So we're open at 3, and then we're talking about everything less than 3. Or, so those numbers are good. -10's good, -100's good. Or values greater than or equal to 2. So 2 is a solution to that part. And all numbers greater than or equal to 2. So what are the solutions? Well, the solutions are anything that is mentioned in this group or this group. And so what we have are the ones that are now graphed on this line. Okay. In interval notation, we can't say it in one interval, right? Because there are two distinct separate intervals. So we have to say the numbers that work go from -infinity all the way down here, all the way to -3, or start up at 2 and go to infinity. Remember, we always go small to big. This symbol right here, that represents the word union. That means or as well. So this basically takes what looks like two separate answers and it glues them together. So basically it's saying, hey, anything listed in one of these two is an answer. So that is the word or. You can use this symbol or you can write the word or. Okay, one thing I neglected to mention back up here at the top is and. So and, first of all, notice the interval notation can be written as one interval because it starts at a low number and it ends at a high number. So we start at the lowest side, 0, and we go to 4. 4 included, 0 is not. In set builder notation, you can also find and written like this. And let's make sure we can just interpret what this says. X is less than or equal to 4. So I always kind of start analyzing that portion. X is less than or equal to 4. It's exactly what it says over on the left side. But then reading from the X, notice this says X is greater than 0. And if you come over here, it says now X, reading from the X, X is greater than 0. So when written together like this, it's understood that this is an and question, and we're looking for the overlap on these. So if you feel like you want to, if it bothers you, you can just rewrite it like this, or vice versa. The two mean the same thing. The little note I have down here on or, these cannot be written together. So even though you could sort of artificially throw these together in a similar fashion, just the act of writing them together, anybody reading your question is going to assume that you're asking for the overlap, you're asking for an and. You're saying they have to meet both conditions. So you just can't, there is no shortcut for writing the or together in one statement like that. Okay, let's move on. All right, so I'm going to do this pretty quick, I hope. Graph on a number line all the numbers that satisfy each of the following. Write the answer in both set builder and interval. So all numbers greater than 0. In set builder notation, that's x is greater than 0. I'm going to do the number line first. So that would be starting at 0, everything bigger than 0, which does not include 0, and goes on forever. And then once I've done that, if I was a little iffy on my interval notation, now I just look at the graph. 0's on the left, it goes forever. 0's not included, infinity's not included. So again, this is the set builder notation, and this is interval. All right, now let's do all numbers less than 6. Well, that's x is less than 6, nice and simple. If you want to draw the number line before you do interval, that's fine. Here's where 6 is. Here's 0, let's say. So now all values less than 6. Everything that goes on to negative infinity, which brings us to the left side is negative infinity and the right side is 6, neither of which are included. Now, part C, it's saying, hey, let's take both of those conditions, greater than 0 and less than 6, and put them together and have to meet both criteria. So hopefully we can see then, since we've already done the number line, that the numbers that satisfy both criteria, 0 is not in both criteria, 6 is not in both criteria, but everything between them is. That's where the overlap happens, right? 5 is in both of my answers. 2 is in both of my answers. -1 is in one of my answers and not the other, so it is not part of my answer. So let's put this together in set builder notation. So we could either say x is, we just basically say these two things together. X is less than 6 and x is greater than 0. You could also write it as x is less than 6, x is greater than 0. So those two statements mean the same thing. And then we're going to use interval notation. So I'm going to start at the left side and go to the right side, neither of which are included. There's my interval notation. All right, let's take a look at D. All numbers less than -4. X is less than -4 on a number line. I'm going to mark 0 here, mark -4, and then all things less than -4. So not including -4, everything going that way. The next one, finish this off. We want to say interval notation, that's negative infinity to -4. All numbers greater than 2 on a number line. I'm going to mark 0, I'm going to mark 2, and then all numbers greater than 2. So everything this way. And so in interval notation, that one is 2 to infinity. All right, so then we do a compound meaning more than one together, inequality, all numbers that are greater than -4 or greater than 2. Well, I don't have to have an overlap. In fact, I'm not looking for an overlap. I just need whatever point is mentioned. If it's mentioned at least somewhere, then it's an answer. And so in this case, we're not looking for the overlap. We're just going to put both of those pieces on the number line. So it's an answer if it's less than 4 or greater than 2. So my answer is going to be all of these and, or I should say, all of these. So in set builder notation, all I'm going to do is write the two statements with an or. X is less than -4 or x is greater than 2. No other way to write that. In interval notation, I have to also write it in two separate statements because there's no way to start at the left and go all the way to the right and get everything that's included. So I'm going to have to say from negative infinity to negative 4, neither are included, or use the union symbol, and then 2 to infinity. So I'm just taking these two statements that we did right here, and I'm gluing them together with this as a single answer. All right, example 2, I've given it to you in set builder. So you graph the points that are solutions to this, and then write the answer in interval notation. So please pause and try on your own. So now I've got all x's greater than negative 2. So here's where I might draw some lines above my number line or below, keeping in mind that's not my answer, it's my scratch work, right? So where is x greater than negative 2? So I'm going to put a circle at negative 2, not include negative 2, and then everything bigger. That'd be everything over here. And then x is less than 4. So I always like to know where 0 is. There's 0. And then so let's put 4 out here. X is greater than or equal to, so 4 is one of the answers, and then we're going less than, so that's going to be going this way. Well, everywhere that they overlap each other is going to be a solution. So not including negative 2, including 4, and then everything in between, because these are the points that satisfy the red line and the blue line. Clearly, there's lots of more red points, there's lots more blue points, but no other red-blue points. All right, and then in interval notation, we just see right what we see. We start at negative 2 and we go to 4. Negative 2 is not included, 4 is included. All right, let's do this next one. Number line. This is a default and, remember. So whatever happens, we're looking for the overlap. So we've got 0 on here, we've got 10 on here. If you want to write them separately, that's fine. We're looking for values less than 10 and x is greater than or equal to 0. So I can already see what's going to happen. X is less than 10, not including the 10. And that's going to be everything this way forever, right? Keep on going. And then greater than or equal to 0 would be then everything this way, including continuing. And so where we overlapped, we're overlapped in between. That's where they share points. So if you want to do them on the number line, that's why I demonstrated this time, just make sure you don't leave the one line going one way, line the other going the other way, and expect someone to know what you're telling them, okay? You need to be very clear and color in very specifically which points are the ones that are solutions. All right, part C. Oh, wait, interval notation. Starting at 0, including 0, and going to 10, not including. Part C. Where are we at here? We've got a 1. We've got a 6. Here would be 0 over here someplace. X is less than 1. That's these guys. Or x is greater than or equal to 6. And that would be equal to. That would be those guys. So now what's the answer? The answer is going to be any point that's mentioned at least once. So that's going to be the 6 and everything bigger than 6 and then everything less than 1. Okay, so those would be the answers. So what isn't an answer? 1's not an answer, and anything between 1 and 6 is not an answer. In interval notation, I cannot write it as one friendly statement like this one. I have to break it up into 2. I start at negative infinity, I go all the way to 1. I don't include either one. Union, or the word or. I do have 6 included, and I go all the way to infinity. And part D here. I wrote it with the union symbol, again, just as a practice. That just means or. So again, I'm not looking for overlap. I'm just looking for anything that gets mentioned at least once. So 0, x is greater than 0. And this one, these are usually pretty easy. That's going to be everything over here. Or x is less than or equal to -5. And that's my answer, right? So I can come back and clarify it if you want and say, okay, here are my answers. We're talking about all these, but it's just the ones we just drew. So probably good enough without embellishing. Negative infinity to -5, including -5, or union 0, not including to infinity. All right, I think there might be one more thing on here. All right, so now it's just a practice of, you've got some images here. Let's list the points that we see. So clearly we see we're looking for points bigger than 2, but we're not going beyond 6. So we're also looking for points that are less than or equal to 6. So interval notation, nice and simple, 2 to 6. 6 included, 2 not included. In set builder, written together, put x in the middle, less than or equal to 6, and read from the x, greater than 2. -3 to -1, both included. Put x in the middle, less than or equal to -1, greater than or equal to -3. -2 to 5, including 5, not 2. X in the middle, less than or equal to 5, greater than -2. 0 to 6, not including either one. And we're looking for values less than 6. We're looking for values greater than 0. Have to meet both criteria. On the other side, very quickly, we've got an interval notation. I can't say it all together. -infinity to -5, including the 5. Union, or the word or, not including 2, all the way to infinity. And then set builder, you just write what you see. X is less than or equal to -5, or x is greater than 2. Cannot mesh them together as an and. This one looks like an and. We're looking for the overlap. So how do I say this? I'm going to say 3/2 to 6, neither one included. X in the middle, less than 6, greater than 3/2. This one just looks like it's one condition. -7 included, all the way to infinity. So that's just x is greater than or equal to -7. And this one would be -infinity to 2. I'm sorry, -2. Or union, either one. Oops, square bracket, including 2 to infinity. X is less than -2, or x is greater than or equal to 2. All right, I hope that all makes perfect sense, and let me know if you need any support.